Sorry. Huh? All right, so by first principles, okay, I just write in one line, right? I just write in one line, right? I just write in the formula and I'll give you 2 minutes again. Right, and then Darian will come and do the homework first. Try it? Yeah. Try it? Yeah. Right, please remember x plus h, wherever you have x, you put in x plus h. Don't forget that. F of x plus h has to go here and here. What is normally happen on top? The x's cancel off, right? The x's cancel off. Normally. Right, let's do this one. Let's do the homework and do a query. Sign. Or shall I? Green. Yeah, but he does now. Carry on to the next. What do you care? Now some man beat me last year, way. Now I'm real quick, way. I'm on real quick. Huh? Son of one, bro. All right, ready? Right, I just doing one more line. Just doing one more line. F of x plus h means 4 by x plus h squared minus 3 by x plus h. Right, that's f of x plus h minus f of x, which is this. Right, but it's important that you put bracket 4x squared minus 3x and you divide all of that by h. Okay. Which one? Now, why you do sign on the board? I'll help you. Right, so when you expand this, you'll get 4x squared. Sorry. I jump a step there, right? You'll get x squared plus 2xh plus h squared minus 3x minus h minus 4x squared plus 3x all over h. I just multiply everything by 4 here one time because I don't want to write back the whole thing, right? I just leave it there. Right? So this will cancel with this. This will cancel with this. All the x terms only, those terms normally cancel off, right? Now we are left with the limit as h approaches 0 of 8xh plus 4h squared all over h. Right? So that will cancel that. So you have this, you have this, you have this. That's it. What to do now? Right? Factor out the h and cancel, right? So you'll get the limit as h approaches 0. And remember here what it takes up, what not to do. Right? Don't just cancel h and h. Yeah, divide everything by h, right? Keshav? You know what you take up? Everything has to be divided by h, right? So it will be, or you can factor out the h as well. You'll get 8x plus 4h minus 3. This h will cancel. And now you'll get something looking nice like this. And you plug in h is 0 and you're done. So your final answer is 8x minus 3. Right? Now, Darian, come and do this sign for me. I'll help you. Come on, try this sign. Can I expand it out? Sign A plus B. Can I expand it out? Or you can use factor formula. Sin A minus sin B. Anyone say oh yeah, just take a look at sin X. Yeah, right, I will send it, right? Just take a look at his sign. Everybody ready? All right, so what's here? I'm doing sign now, right? All right, so watch this here. Marquis, show up now. Watch here, please. Let's differentiate sin x. What's the differential of sin x? Cos x, right? Okay, nice. So plug it in here, you'll end up with sin x plus h minus sin x. When you all reach here, you have two options, Javed. You have two options. You could use sin A minus sin B. If you remember your factor formulas, one likely you don't, right? Or you could use, you could expand sin A plus B, right? So you can expand this using the compound angles, right? That will give you sin x cos h plus sin h cos x minus sin x all over h, right? What I can do here, bring all the x's together, bring all the x's together. So I'll end up with sine x cos h minus sine x plus sine h cos x, right? And I'm going to put everything over h. That's okay? And just splitting it up, right? So I'm finding the limit. Actually, limit don't jump any steps so you don't get lost, right? So all I did is I just bring the minus here and I just bring that there. That's okay? So I'm going to find the limit now of here and here. I'm going to find the limit of both of them. Online. All okay? Scale up. Right? So I reach here, I expand it out using compound angles, and I bring the sign here. And I end up with this. Okay? I'm going to use limits now and break them up. The limits as h approaches 0 of sine x, I'm working on this, cos h minus sine x on h, plus the limit of sine h cos x all over h. Okay, I just split it up. What I could do here now is I could factor out sine. So I'll get the limit as h approaches 0 of sine x cos h minus 1 over h. I have a question, right? Since we're looking at how h behaving, Keshav, right? You want to look at how h behaving. With h affects sine x? No, because this is dependent on x, right? So as h approaches 0, it will not affect sine x. So technically, sine x is a what? Constant. And if you remember your limit rules, I can take it and bring it out here, right? So I can bring sine x out here. Look back at the rules I gave you for limits. What this is. What this is. Check your rules and you'll see that this is 0. So you'll end up with sine x multiplied by 0. Here now, can I do the same thing? Can I do the same thing there? And pull out. So I can pull out the cos x here, right? And I'll get the limits as h approaches 0 of sine h on h. What is this value here? This value is 1. So I'll get cos x by 1. This is 0, this is 1. So my final answer is cos x. Right, Darian? That's all you have to do, Darian. Everybody okay with that? Right? So this is one way you can do it. The next way is to use the factor formula, whichever one you remember. Okay? Copy it down. And it works for cos, sine, and tan. Copy it down. Let's do a square root. Copy down. Let's do a little square root. All right, let's go again. Anybody writing? Right, for those who want, like, Samira, do this one and come on the board and let me see what you get. Square root of 2x. Try that fast. Marky, shut up, man. You're thinking of doing it. You're thinking about. Next week, do class online and person. Oh, yeah. I know, it's fine. She's definitely I don't want you to get. I don't want to. Right, are you listening this, right? Yeah, we gotta hurry up now. Try this fast. Right? You're going to have to try to rationalize somewhere, right? Yeah. You're going to have to rationalize somewhere. Here are next news. This question, please. Please. What can you do it? Oh yeah. Online, take your time for this one, right? What? What foolish? Ready? Okay, sharp. Number is we can put now. Right, so Keshav, what to write here? What to write here? Square root of 2x plus 2h, right? Is 2 by x plus h. Okay, so the square root of 2x plus 2h minus the square root of 2x all over h. When I reach here, Samira, what do you think I can do? Because I have a big problem here, right? I have a big problem here, right? If I put h is 0 and h is 0, it wouldn't work out. I'll get undefined, right? What to do? Right, so you multiply by root 2x plus 2h minus root 2x on top and underneath. Right, that I was just I do a TikTok and I tell you why it's not square root of 2x plus 2h plus, right? Well, yeah. Whenever you're doing questions like this, right, Shaq? Whenever you're doing questions like this, don't try to multiply it out. Just write underneath, just write h by this, right? It will simplify out nicely, right? So just write h by the square root of 2x plus 2h plus the square root of 2x, right? Don't try to multiply h by this and h by this. Just leave it like that, right? What would the numerator be? And multiply this by this. What's the numerator? 2x plus 2h minus 2x. Right? That's the difference of two squares, right? So you'll end up with 2x plus 2h minus 2x. What would happen to the 2x? Cancel, right? And then when you reach here, Jacob, what to do? Yeah. When you reach here, Jacob, what we can do? Cancel off the h. Very good. Right? So that's why I know why you're multiplying it out, right? And then what it to do now? Darian, what we can do now? We have 2 over that. Substitute h is 0, right? Substitute h is 0, and you'll get 2 is equal to the square root of, here becomes 0, plus 2x. What's the square root of 2x plus the square root of 2x? What you'll get? So you'll get 2 over 2x, right? 1 of this plus 1 of this is 2. 2 will cancel, and you'll get 1 over the square root of 2x. Is that the answer? Yes, sir? Yeah? So I'll put in h is 0 here. Yeah. And it becomes 2x. This part becomes 0, right? Oh. So it's 2x plus 2x, which is 2x. And then it cancels. All right? So that's the first principles there. When it's sure about finish, I'll just wait. When it's sure about. No, but why don't understand here? You people for the how I get this? And I multiply by the conjugate here, right? Right? I multiply by the conjugate of this, and I get rid of this square root. And I end up with this line here. The x's cancel off like normal. And when I reach here now, I factor out the h's. I cancel out the h's. And then I plug in h is 0, and I get root 2x plus root 2x, which is this. Cancel to give me this. Next one. One more. No. Last one. 1 over the square root of x. As a past paper, right? Try that fast. 1 over the square root of x. At the last one, Keshav. Take your time and do 1 over the square root of x. Kivish, try with a pen in your book. Thanks. Excuse me, watch up there, watching something here. Good. Take a time as a fraction. We gotta simplify. Look, it's the same thing. Holy. Javed, the actual do the question now. Right online, take your time, right? Because you have to simplify the numerator before you start working it out. Oh gosh, boy. Greedy. Take your time with the numerator. The numerator problem there, right? Giving you a few minutes again, let's see if we get it. By the way, what's the answer? 1 on root x means x to the minus a half. Bring down the power. Minus 1 for the power. So you should end up with minus 1 over 2 by the square root of x cubed. Right? That should be a final answer. Right? That's what the answer should be after you do it. Online, if you get it, just message yes, right? Message yes. Selena, are you doing it? Selena is doing it. All right. Right? Anybody get to online, just message yes, right? Okay, we need. Oh yeah, faith. Question of faith. Oh. All right, so you should have 1 over x plus h minus 1 on root x all over h. You found the LCM here? You gotta find the LCM here, right? So the LCM here will be root x plus h by root x all over root x minus root x plus h. All right. So if you find the LCM here, this by this, that is denominator. Numerator is 1 by this, and a minus sign in the middle. That's okay? So this simplifies to this. Everybody okay with that? Yeah? Keelan, what I could do with this h here? What I could do with this h? Bring it up, right? So I'll end up with the limits as h approaches 0 of root x minus root x plus h all over h by, can I multiply these two things here? Right? We can leave it like that for now if you want. Root x plus h by root x. So this whole thing becomes this. When I bring up the h, it looks like that. That's okay? So if you get confused before I move on. Yes, who confused? Where you confused? Nah, start back from here, but I wasn't paying attention. Huh? Right, so we're doing first principle. You just want the answer. Right. You all understand the rule? Yes, sir. Right. So all I'm going to do is I'm going to plug in H. Right? So I'm going to plug in H here and well, leave it without H, right? So you follow this first line. Yeah? Follow the first. Hey, I'll explain it over for you. For you, Marquis. Right. Watch here. How do you simplify a fraction? This picture coming out tonight. Watch it. All you're doing is this. Right? Remember the same thing over and over. A on B plus C on D. How you simplify this? BD, AD, BC plus sign in the middle. Right? You're doing the same thing here. Right? This by this. This by this. This by this. Minus sign. That's what I did. I said the same thing on the fourth. Here. So a fraction over a fraction, I can bring up the h. To make it look nicer, which one looking nicer? Now I have one instead of a fraction over something else. What? Tell me. Boy, you don't answer how this became this? Tell me. Yeah. Yeah, you're dividing by h, so you're multiplying by 1 on h. That's all right? Okay with that? Right. So when you reach here now, here is where you can kind of rationalize it, right? So here is where you can multiply by. Here is where you can multiply by root x plus h all over root x plus h. That's okay? Don't expand anything out. Leave it just like that. Right? What will the numerator be K sharp? You see, I explain anything for you, you're not paying attention. Right? So watch here. When you multiply this by this, what you'll get? Numerator. You'll get the limit as h approaches 0. You'll get what? X minus x plus h. Correct? Yes. When I multiply this by this, I'll get that. Yeah. Now, the denominator, I'll leave it just like that. I'll leave it just like this. So I write in h by root x plus h by root x, open brackets, root x plus h. So this is one big product. I'll leave it just like that. Everybody okay with that? And not expanding it out. Now, what will happen on top here? Right? On top here, you'll get x minus h, which is minus h. See that? I mean, Keshav. And then you have H by all of this. I just put in a bracket outside so that you always see everything is multiplication. What to do with the H? Right, the H will cancel and you have -1 on top. Right? And what's the last part of it? Right, put H is equal to 0. When you reach here, you can put in H is 0. Right? Or you just know when to put in H is 0. Right? You put in H is 0 when the limit will no longer be indeterminate. Okay? If I plug in H is 0 here, and I'll get 0 underneath, which is infinity. If I plug in H is 0 here, I'll get infinity as well, right? But if I plug in H is 0 here, that won't happen. Okay? You'll end up with -1 over, this is 0, so you'll get root x by root x. This is 0, so I'll get root x plus root x. Take your time and multiply this out. Root x by root x is x. Right? What is root x plus root x? Trying to explain anything for you and take up while you're on your phone. Right? Root x plus root x is what? 2 root x. I am done. What is x by a half? What is x by a half? 1 plus a half is what? 3 and 2. Okay? So you'll end up with -1 over 2x to the 3 and 2, which is exactly what we have there. Okay? I can make it look a little more like how I wrote it. 2 by the cube root of x. Same thing. Huh? Yeah, checking your notes. But okay with that? Yeah. Right? But again, here's one important excuse Tarian. Here's one important, right? You have to simplify the fractions, right? And turn it into one nice fraction and then apply the search. I mean apply the rationalization. Yeah. Yeah. Huh? One right next one. Yeah, I'll tell what you're doing. All right, copy that down and head up the normal differentiation now. Let's take a look at normal differentiation. I'm going to write down all the rules here, right? So do you remember it? All right. So head of differentiation, let's run over some rules quickly. Hey, wait. Right there. Oh yeah. Well done. Yeah, should be. All right, let's go. Darian, Olia, everybody, watch up here. All right, so we're going to take a look at differentiation. Right, I am going to just go over things that I should know in differentiation, right? Right, so some of things that we should remember. If you have to differentiate ax to the power n, that will be n ax to the n minus 1. All right, so you have to remember how to differentiate those things. Suppose I ask you to differentiate ax. Well, yeah. Hey, Marquis. Well, watch up here now, please. dy dx is a. Okay? dy dx is a. If I ask you to differentiate a constant, then dy dx will be 0. Right? There's some basic things to remember. Right? We also need to remember this shortcut method. How do we differentiate ax plus b to the n? You have to tell me the steps. Shortcut. And on the outside. Right? Bring down the power. Differentiate a. Write back ax plus b. Right. How else we can do this? Darian, just pay attention. You know. Yes. Right? What's in the next way that we can differentiate this? Use chain rule, right? So you'll get dy dx is equal to dy du by du dx. Right? Remember, you could also use chain rule for rates or change and thing, right? Instead of u, it becomes t basically, right? Nice. Our next rule that we should remember is what? We should remember product rule. Product rule is what? U by dv dx plus v by. Nice. What is quotient rule? Right, just some rules to remember. Yeah, you can just do that. Play another question. Anyone that looks, you can do that as well. Right. Darian, what is this here? What that is? This is the Jelania. What's it again? Yes, correct, Darian. This is your second derivative. Right? d2y over dx squared. All right? This is your second derivative, right? Right? Javid, do all these here for me. What's the differential of sine ax plus b? What will that be? Vinesh, yes, Javid. What's the differential of sine ax plus b? Right? You differentiate ax plus b, you get a. Differential of sine is, and you write back ax plus b. What's the next way to do this? Right, the longer one is to use the chain rule. Right? You could also use chain rule. Tell me what's the differential here? Cos ax plus b. It will be, right? The differential of cos is minus. It will be minus a sine ax plus b. Okay. What about number 10? This one a little bit new, but we can actually work it out, right? What's the differential of tan x? X squared. But how we can actually work this out, Darian? The differential of tan x is x squared. Right. Use quotient. Right, Darian? What you can do again, Darian? To differentiate this. Pardon me? Okay, that's an option, right? But an easier option is just to use quotient rule and use tan as sign on x. All right. So these are some of the rules that we need to remember, right? Right. And next rule I need to remember. I need to rule this one. Next rule. Oh yeah. Do the sum specific again, this please. But use quotient rule, not limit.
Is this one?
Alright, sorry. Right, so these are the things that you need to remember for differentiation. We'll do something that's not right. I just want to point out something as well. Right? What you're saying. Whenever you differentiate, right? If you differentiate dy dx with respect to x, you'll get d2y dx squared. Right? If you differentiate y with respect to x, you will get dy dx. Right?
I think so.
So I know it sounds like common sense, but there's a question or two when we're going to use this. Technically, this is something called implicit differentiation. This is unit 2. Right? But if you see this, you can do it, right? If you differentiate y, the answer is dy dx. So for example, if I ask you to differentiate this, the differential of y is what? And the differential of 2 is 2. You've been using it all the time, but there's a right? There is a point in time, but if I remember what the question was, the question looks like this. How would you differentiate 2xy?
I got yeah, let's say it's equal to dy dx and then minus is another fraction, but it's not really a fraction. And you bring it across and put
All right, so a little lost there, but what you can do is this.
and add it integrate.
So what you can do is use sort of rule. Kind of, yeah. Right? So what you will do is something like this, right? You're going to use something like this. Du dx is 2, and you're going to see that dv dx is dy dx. Okay? And then you're going to product rule and bring all the dy dx together. Okay? So although you've been doing this all the time, right? This is a rule that you're going to be allowed to use now. Okay? We'll do an example lesson and you will see. Yeah. I'll think about it. No, 1/2 7. Yeah. All right. So I just wanted to remember that. Right? What was one of the applications, Jaden? What was one of the applications of differentiation? A really easy one. Right. Stationary points. So when dy dx equal to 0, stationary point occurs. Remember that?
Yes.
And what would happen if d2y dx squared is more than 0? It's a minimum, right? And what would happen if d2y dx squared is less than 0? Right? What has happened if d2y dx squared is equal to 0? A point of inflection.
Yeah.
Right? Something that looks like this. Minimum looks like this. Maximum looks like this. Inflection looks like this. Everybody okay on that? So we're going to spend some time on these here. So head of stationary points. Right? Copy down all the rules, head of stationary points. Come on. Marquis, take a copy down, please, Marquis.
I finished.
Copy down all that.
Yes.
All right. So before we do that, let's try a question here from a past paper. Yeah, how old are you? Right, 2017. Let's try this first and then we start the application, right? Alright. Try this, please. Try that, please. 2017. That's part C we doing. Oh yeah. Try that, please. Excuse. Right, I'm giving you out 9 minutes. 9 minutes. Hey, Jasper, how you have to start YouTube? Do the question quick now. You can still do the question, the best thing to get that's up. Do that fast. Hurry up.
It's one time, one time.
All right, let me go. Y'all get? Huh? No. Yeah. Your 9 minutes almost up. Your 9 minutes have about 2 minutes again. Yeah, you sit there until I leave now. So they sit down talking there and expect to finish. I'm gonna start with this now, right? It's key again, you'll recognize here, faith, how far I reach. Right? The key is simplifying it, right? Right, so part A, we have to show that y dy dx. So we have to get dy dx multiplied by y and get that. Yes, anybody get you part A?
Yes, sir. Yes, sir.
Yeah?
Yes, sir.
Right, want the part B, want that? So you have to differentiate everything inside the bracket. So 2 plus 2x squared. All right, take this off. Anybody get it online? Right. Take up how far did you get it? What is the proof, right? So y is equal to 2 plus 2x squared to the power of a half. When you differentiate this, you bring down the power. You differentiate inside the bracket. You write back the bracket. And you minus 1 for the power. So you're going to get half of 4x and 2x over the square root of 2 plus 2x squared. Right? This is your dy dx. Right? Anybody recognize what this is?
Yes.
What this is?
I see.
A third.
Oh.
What else? Victoria, what this is here? Y. Right? So you have dy dx is equal to 2x over y. And can I multiply? Can I cross multiply now? So I'll get y by dy dx is equal to 2x. And I could bring the 2x on this side. So I'll get y dy dx minus 2x is 0. Right, Darian? So I had to do that, Darian. Pardon me. If you wanted, yeah. If you wanted, you could have. If you want, yeah, substitute y here, you could have done that. And you'll get 2x minus 2x is 2. But you find mine looking nicer than yours? Huh? Yeah. Right? What's the next one again? Last one is this. D2x, sorry, D2y. Do this, please. D2y dx squared. So try and differentiate. What's earlier? Try and differentiate this one, not this one. If you differentiate this, you have all this to simplify out, right? But if you differentiate this, you have u and v. That's okay? And I showed you how to differentiate y, right? So it's easier to do it working with this. And Samira, easier with this, right? And instead of using these square roots again. But you can do it, yeah? Because you already know how to differentiate that. Okay? Anyone could work. Huh? Oh yeah. Samira, let me just track here, please. No break today, boy. Who want the break? Who wanted the break? Work it out and then the break. If three are working it out, I'm doubling the break today. If three are working out that, I'm doubling the break. If three of them don't get it out, no breaks. Yeah. I'm fine, okay. Go by that way.
Yeah.
Take your time, right? Try to work out this first. Like for the way it's supposed to. Differentiate as product rule, right? I mean, quotient rule. Always on correction. Take your time on simplify. Yeah. Well, and something like you do your work. Huh? Yeah, you do your thing. Go ahead and the shot here. Time almost up, right? I'll show you. So if you differentiate y with respect to x, that'll be dy. Yeah, but because the differential of y tells you what's it. If you differentiate it, what you'll get dy dx because y is a function in terms of x. So when you differentiate y, you just get dy dx. Yes. So it's not like a differential in the y and the x and the 20. Anybody get? Anybody online get? Feet of fire, which feet? All right, time up. Yash, did you give up?
Yes.
Right, so we start in here. dy dx is equal to 2x over y. Okay, so I'm going to differentiate this, right? So d2y dx squared. This is u, and this is v. The differential here is du dx. Du dx is 2. The differential here, dv dx is dy dx. Okay, I got a quotient rule here, right? Quotient rule is what? That's now we can jab it on here, inshallah. It's v by du dx. So it's y by 2 minus this by this. All right, game done now. Right? So y by 2, this by this, minus 2x dy dx. Right? All over v squared, which is y squared. That's okay? So let's simplify this out. d2y dx squared is equal to 2y minus 2x. What is dy dx? 2x on y, and so can I write 2x over y all over y squared? Right? What does this simplify to? 2y minus 4x over y all over y squared. Right? Problem, I want to simplify it a little bit more, right? I showed you how to simplify two fractions and a sign. 4x, oh yes, 4x squared. Right? I'm going to simplify here. So I'll get y by 2y squared minus 4x squared. What can I do with this y squared again? Bring it up. So I get in y by y squared. Right? So I'm ending up with 2y squared minus 4x squared all on y cubed. That's okay? We're almost done. Right? We're almost done. We need to show that this minus this is 0. Right? So we have a few options. We could take this and put it in here and then cross multiply and simplify it. Or we could put in what y is and simplify it. It's up to you. But I will substitute. I am going to substitute d2y dx squared into the left-hand side. So I'll end up with 2y squared minus 4x squared on y cubed minus 4y cubed. Right? Let's see what this simplifies to. Yeah. Right? So everything is over y cubed. And here you have 2y squared minus 4x squared minus 4. Right? I need to get 0. So it must have a way for me to simplify all of this, right? Anybody recognize this? Besides that, what is y squared? Y squared is what? 2 plus 2x squared. So what is 2y squared? 4 plus You're saying that? So if I come back here now, I know that 2y squared is 4 plus 4x squared minus 4x squared minus 4. What would happen here? That's okay? So what I mean, even if it didn't see all of that, all you had to do when you reach here was substitute y. Y is this. Right? When you square it and multiply it by 2, you'll get it. That's okay? Okay? This question was more about simplifying than differentiating, right? But I want to point out something. Instead of you trying to differentiate here, right? Instead of you trying to differentiate here, it's much easier here. And but it could be done here as well, right? Because you can substitute back for y anyway. That's okay? All right, let's go again.
The best copy that out.
Huh? Yeah. Copy it down. So again, the question. Now, no way. Because how much time again? I'll finish it 5 minutes ago. But I was on a break all the time anyway. Talking. I was 2017.
Because I see that they.
I copy down and let's just take a look at the point of inflection now. Any questions here? Victoria? Are you experienced? Jack, you okay with it? How far are we? How far are we, guys? Oh?
This one.
All right.
Yeah.
Okay. Huh? It's a build up. It's a one like when you do this right, question the equation. I can say that I know by this is just a foundation. The one is the effect of equation. It's happening. I think that by having the foundation from the next step. But you would never go without different. But it's just based on where it comes. Big application, I did research. For example, like the go to check it out so you
It's a good.
right that way like 8 seconds. Like even on plus so Yeah, yeah. Yeah. All right, ready? Samira one. Samira. Huh? Samara. Why is it Samira? Samara, one. Sure? Yeah. Victoria, which part you don't understand? Victoria, come fast, I'll show you. Yeah, you can put it, you can come fast, I'll show you.
What you did, I see.
Which one? Yeah. Right, I differentiate V, I get d dx, and the differential of y is dy here. The V on technically, but remember, y is a function in x. So y is like 2x minus 1. So technically, y is a function in x. So I am differentiating v with respect to x. So although I have y here, y is a function in x. So technically, I could have written this instead. Right? So when you differentiate v with respect to x, you get dv dx. When you differentiate this, which we call y, we get y with respect to x. It's like if you had, so it's like y being a function, right? Y is not just the letter y. Y is not a variable here. Y is a function in terms of x. Because the differential of y is dy dx. If we differentiate anything, if we differentiate any function y, we're gonna get dy dx. So if I differentiate this, what you'll get? You'll get dy on dx is 2. This is saying the differential of y with respect to x. So although I do have that, y is a function in x. Okay? That's why I have it with respect to x underneath. And that's why we do with respect to x as well. Right, so I wanted to show you one more thing, right? Huh? All right, so watch this here. All right, watch up here. Last thing that we're doing, right? The last thing that we want to do is we want to identify our stationary points, right? We already did max and min and thing in Form 5, but I want to focus on something called a point of inflection. All right? And I want to focus on something called the first derivative test. These things we know already. If I look at this maximum, right? How is the dy dx behaving here? For those who remember gradient, remember dy dx in gradient, right? So the gradient increasing here. So from here to here, we can see that dy dx is greater than 0. What about here? We can see that dy dx is less than 0, right? So if you find dy dx, And you recognize that when you plug in an x value before the stationary point and it's more than 0 and after it's less than 0, it means that we have a maximum point. That's okay? That's what you're learning from 5, right? For a minimum point now, let's say this is x is 4 and you plug in x is 1 and x is 9. Here's what will happen, right? You pick a value before 4 and a value after 4. Here's what will happen. You will see that dy dx is less than 0. And here, dy dx is more than 0. Right? So if you go from less than to more than, that is called a minimum point. Right? Here is maximum, here is minimum. The point of inflection, on the other hand, how it's looking? Anything different about two of them? The point of inflection is what? What you all recognize? It's staying increasing or it's staying decreasing, right? So you would recognize that if you choose a value before the x value and the sign is more than and it stays more than after, it's a point of inflection. So there's a sign change here. There's no sign change here. That's okay? That's your first derivative test. Right? So if dy dx is less than 0 here, if dy dx is less than 0. Right? So if there's no sign change, point of inflection. If there's a sign change, there's a point of inflection. Right? Copy them down. Max, min, inflection. Right? And let's do one example. Online, hello, Peter. Hello. All right, last one earlier. So in this one here, in this last one here, we need to determine the nature of the stationary points, right? If it's max, min, or inflection, right? So step number 1 is to find dy dx. dy dx is what? Minus 4x cubed minus 6x squared. That's okay? And you should remember that stationary points occur when dy dx is 0. So take minus 4x cubed minus 6x squared, make it equal to 0. Tell me all again now. Yeah, you can use a calculator. But you know what you need it. Right? You should get x is 0 and x is minus 3 and 2. Check and see fast. How? Right? You're okay with that? This is Darian. If you could listen to me instead of listening to them, please. Pick it up, you're fine. All right. Are you ready? So now here's the problem, right? Of course, you can go and find your y value, right? Of course, you can go and find your y value. So I want to do the first derivative. Call your hey, watch here now. I want to take a look at the first derivative test. Right? Let's take a look at the first derivative test and check and see which is max and which is min. Of course, you'll find the y value, right? But you'll do that homework. For sure. All right. Here's what we're doing. We want to see if it's max or min based on doing the first derivative test, right? So our two stationary values are what, Darian? What are our two stationary values?
0.
Darian? So your stationary values are here and here. That's okay? Right. So watch this here. Right? So the first thing we need to do is let's check out 0. Let's check and see if 0 is a max or min. All right. So watch this here. We're gonna choose two values to the left and to the right. But I want you to check something out, right? To the right, easy. There's no other stationary value here. That's okay. So it doesn't matter what you choose, right? So I'll do it in another table, right? dy dx x. Right. So as I said, sorry. So I'm gonna choose two values like what I did here. Remember I gave you an example here? X is 0 here, I'm gonna choose a value here and here. What are two nice values to choose? I want to choose on the left and right as 0. Right. What would have happened if I end up choosing -2? Right. It wouldn't work out properly because there's a stationary point before -2. So you have to be careful not to choose those values. Okay? So if you wanted, you could also choose -0.5. The reason why I want to choose -0.5, it don't really matter. Okay, just do that. Right? Is that I'll leaving -1 and -2 for the next one. But it don't matter. It don't matter. I'm choosing -1 and 1. So I'm choosing -1 and 1. Right? And let's check it and see. Let's check and see now, right? Plugging -1 from here, Kevin. What you will get? I just want to know is more than 0 or less than 0. Plug in -1 in here. What you will get? More than 0 or less than 0. Huh? Less than 0, right? And then plug in 1 in here now. What you'll get? Plug in 1 in here. What you'll get? Yeah. Less than 0. Did the design change? The design change. So what does that mean, Shana? Pay attention, please, Shana. The sign didn't change. So what does that mean? Therefore, is a point of inflection. All okay with that? Shaq, we do the same thing here now. What if choose here, Shaq? All right. So you personally would choose -1 and -2. We already know that -1 is less than 0. Or what -2? What you get? Do it fast. No. Huh? Right? You will get more than 0. So if you go from more than 0 to less than 0, max or min? You'll get x equal to minus 3 and 2 is a maximum. You okay with that? If you go from more than to less than. You okay with that? Everybody okay with that? So this is the way, this is the test that you use to show inflection. Everybody okay with that? Stop here down. No, we have a question to do now. So that means they have 5 minutes to do it. Yeah. Stop here down. Right, so these are the things that you have to learn in differentiation. Technically, this all you have to learn in differentiation.
Yes, sir.
Right? You still have research, we have to practice something, but the rest of things is
Yeah.
right. So that graph part, the graphical part, I did it when we did transformation. That is technically I just use, but I will reveal do it. Huh? No, we got some examples on it. But the same thing that you do there, you can do using this. Like finding asymptotes and shifting the graphs on it. Okay, so nice. So we'll do a couple more differentiation next day, and then we have integration, and we are done with module 3. Huh? Yeah, looking for it. Yeah. Hold on right there. You pick it up.